So what's all this zigzagging in the performance all about? Well, if you think about it, this is what the third loop around the microkernel computes. It does an update of a big block of C being updated by a column panel of A times a row panel of B. And then what happens in the loop is that the column panel of A is partitioned into blocks. And then if we parallelize with 4 threads, then the first thread does a computation with the first block, the second thread with the second block, and so forth. The block sizes that we've chosen for A, MC, and KC are 72 by 256 if you look inside of the makefile. And what does that mean? That means that if we're running small problem sizes, less than 72 by 72, only one thread is going to have any computation to do. Up to a size of 144, we're only going to be able to accommodate 2 threads, and so forth. It's only once we have 4 full blocks that we actually end up being able to use all threads effectively. And then it starts over. Then we only have 1 thread that has an additional block to work with, and so forth. And that explains the zigzagging that we're looking at. Now, you may want to try to modify your code in such a way that it does exactly what is happening right now for a full set of blocks, and that of course has to be a multiple of MC and the number of threads, and then takes the remainder and partitions it evenly among the threads so that each individual thread doesn't get optimal performance because it's not working with a full thread, but at least you're using all of the threads. And if you do that, then you can actually smooth out the performance somewhat. So if you feel energetic, you can give that a try. And the code gets a little bit messy. What I did was I split it up into 2 loops, a loop that deals with the part that is a nice multiple of the size MR and the number of threads, and then a separate loop that calculates what the stride must be in order to evenly partition this among the number of threads that are available. Now, one thing you have to keep in mind is that our loops only work for problem sizes that are nice multiples, in this case of MR. So that second loop, you need to be very careful with what stride you pick. The stride has to be a multiple of MR.